Okay guys, this is the start of video number 3 for proportional and non-proportional. Everything that we talk about in video 3 is going to be a non-proportional relationship. So the very first thing I want you to do is go ahead and pause the video. I know we just started, but pause the video and come back and you can tell me what the graphs from the fitness connection and Fit for Life have in common and what is different. So go ahead and pause your video and come back when you're ready to answer those questions. Okay, so what do the graphs for fitness connection and Fit for Life have in common? Okay, well they are linear because they are both straight lines. Okay, what is different? Well, Fit for Life, that seems to be a proportional relationship, and I know that because it's a straight line and it goes through the origin. But over here, for Fitness for Life, it seems like it starts at 0 and then 20. So that's not starting at the origin, so that's a little bit different of a start. So this is a relationship that's not proportional. So let's see if we can figure out why. So plot the X and the Y values from each graph in the tables below. Okay, so we have fitness connection first. So I'm going to move this back up. So we have 0 and 20, 1 and 30, 2 and 40, 3 and 50, and 4 and 60. Okay, so 0, this is going to be my X, and this is going to be my Y. And if you'll notice, I have a process column in here. So for 0 visits, it's going to cost me $20. For 1 visit, 30. For 2 visits, 40. For 3 visits, 50. And for 4 visits, 60. So what's happening? Well, for my process column, he is pricing 2 local gyms. He used the graph to answer the question. So I don't even visit, and it cost me $20. So that's a little bit weird. So then I have, it cost me $20 and I have 30 more. So it seems like I'm paying $10 every single time we visit. So if that's true, I would have 0 times 10 plus 20. This one would be 1 times 10 plus 20. And 1 times 10 is 10 plus 20 more is 30. So this one would be 2 times 10 plus 20. 3 times 10 plus 20. 30 plus 20 is 50. And 4 times 10 plus 20 is 60. So it seems like this one had an initial value of 20. Now over here, I have spent $0 if I have a visit. For 1 visit, it costs me 10. For 2 visits, it costs me 20. For 3 visits, it costs 30. And for 4 visits, it costs 40. Okay, and guys, I'm getting these values from my graph up here. That's where all that information is coming from. So let's think about the process. Obviously, this one is multiplicative. This one looks a little bit more like the ones that we've been doing in class. So $10 per visit would cost me nothing. $10 for 1 visit, 10. $10 for 2 visits, 20. $10 for 3 visits, 30. And $10 for 4 visits, 40. So what do the tables for Fitness Connection and Fit for Life have in common? Well, they both charge $10 per visit. Nope, not 20, 10. $10 per visit. However, at Fitness Connection, there is a $20 fee before we visit. Okay, so that's the difference. Oh, sorry, I didn't move it up. So what do the tables for Fitness Connection and Fit for Life have in common? Well, they both charge $10 per visit, but how are they different? Well, the Fitness Connection charges $10 per visit, but they also charge that $20 fee. So that's how it's different. Okay? So remember, guys, if any time Mrs. Brown goes too fast, you're more than welcome to pause and we can go back. Okay? Non-proportional relationships. A relationship between two quantities is non-proportional if the ratio between the two quantities is not constant. So y'all been doing a lot of questions about which points do we pick and how are we supposed to know, and that we're getting there. A graph of non-proportional relationship will not pass through the origin. Instead, a non-proportional relationship will start at the y-intercept. If you noticed on the very first graph that we went to, our initial ordered pair was 0 and 20, which means we didn't go over anything, but we went up 20. Our y-intercept, our initial value, was 20, and that's where that comes from. So if that happens, if we start on a number other than 0, it is a non-proportional relationship, other than 0, 0 at the origin. A non-proportional relationship may still be linear. We learned that it could still be a straight line, but it's not going to be a straight line that goes through the origin. So that's the difference. At Pizza Palace, George orders a pizza that costs $8 plus an additional $2 per topping. Use the information to complete the following. Complete the number of toppings and the cost of the pizza. So I know that if we have 0 toppings, that's going to cost me $8 plus 2 times 0. And that's going to cost $8. For 1 topping, it's going to cost me $8 plus 2 times 1, which is 10. For 2 toppings, 8 plus 2 times 2, which is 4. So my cost would be $12. 3, my $8 initial value, plus $2 for 3 toppings would be $14, because 2 times 3 is 6, and 6 plus 8 is 14. Okay, $8 plus 2 times 4. So 2 times 4 is 8, plus 8 more is 16. My $8 pizza plus 2 times x equals y. Okay, what is the rate of change shown in the graph? Okay, so we're looking for the rate of change, the change in my y and the change in my x. So I go from 8 to 10, and that is 2. And I go from 0 to 1, and that is 1. My rate of change is the change in y over the change in x. So that's going to equal 2 over 1, which is 2. So my rate of change is $2 per topping. What is the value of the y-intercept? Well, the value of the y-intercept is that initial value that we started with. And it told us that we order a pizza, and that pizza cost me $8. Okay, so that's my initial value, $8 or $8. Is the table proportional? No, because it does not go through the origin. It does not begin at 0, 0. Belongs at 0, 8. Using the table of values, create a graph to show the relationship. So we have our x value of 0 and our y value of 8. So we're going to start right there. For 1, our x is 1, our y is 10, our x is 2, our y is 12, our x is 3, our y is 14, our x is 4, our y is 16. Okay, so even though this is linear, it is not proportional. Okay, what is the rate of change shown in the graph? Well, it's the same thing as it was shown right here, because this is a representation of this. So it's still going to be $2 per topping. What's the value of the y-intercept? 8. Let's just say 8. Let's not say $8. I want to get 8. Okay, is the graph proportional? No, because it begins at the y-intercept and not at 0, 0. Does not begin at 0, 0. Okay, then it says to write an equation to represent the relationship between x, the number of toppings on a pizza, and y, the total cost of the pizza. So it's going to be y equals 2x plus 8, or y equals 8 plus 2x. Either one of those would be correct. All right, guys, I'm sitting at about 10 minutes. You know that it'll cut me off at 15. If you would like to practice using these different non-proportional relationships, what I'm going to encourage you to do is pause the video now, complete this, and then I will come back and I will go over your answers with you. Okay, so what we have here is a situation, and then we have to figure out who did the best representation of this situation, whether it's Frankie or Dean. So our situation is y equals 50x plus 150. So we know that 150 is our initial value. And then we have the 50 times our x. I'm sorry, I lost my train of thought. So if I put in 1 as my x and 200 as my y, so let's do that. So I have 200 is equal to 50 times 1 plus 150. And that's just that first ordered pair right there, guys. That's where I came up with that information. So 200 is equal to 50 times 1, which is 50, plus 150, which is 200. So Frankie definitely represents that situation. Let's look at Dean. So Dean says, if I have one train ticket, it would cost me $150. Well, that's not true because it would cost me $200. And if I have 2 train tickets, it would cost me $250. So Dean is the one that's representation does not match. So Frankie for this one would be the better representation. So for number 2, we have the number of pounds. This is going to be our x, and the total cost, which is our y. And then Frankie says a shipping carrier charges $5 per pound plus a $3 signature fee. What is the total cost of the shipping various packages? And then my boy Dean says C equals, so my y equals 3 times my x plus 5. Okay, so let's plug in this one of these initial values. Let's plug it into this one first because it's a little bit easier. So for our c, or our y, we're going to have 28 equals 3 times our x, which is 5, plus 5. So 28 equals 3 times 5 is 15, plus 5 more. That's 20. So this one would be our correct representation, a better representation. Okay, and we've already corrected it as we go because we are we did the work for this equation right here. So for the next one, our initial value looks like it starts at about 24, and then we might go down 1.5, and we know that this is a negative correlation because it's going downward. Okay. The relationship between the number of gallons drained from a bathtub, T, and the total number of gallons in the bathtub. Okay. Well, the relationship between the number of gallons drained from a bathtub and the number of minutes it has been draining, which is M, but it doesn't give us anything about that initial value. So this one's going to be the better representation, and that's just because this one did not give us an initial value. Okay, I'm sitting at about 13 minutes, so I very quickly want to go over this with you. The answer to number 4 is going to be A, $2.50 per gigabyte plus a $10 fee for going over. And then for number 5, what does the X represent? Well, that's the number of weeks. And the Y represents the total amount saved. Okay. The rate of change is going to be 15. And the Y-intercept is going to be, and because I know the rate of change was right here, and the Y-intercept is right here, the Y-intercept is going to be 35. And we will practice some more of this in class. Thanks for paying such good attention.